A little function yoga. That's what I like to say. No one thinks that's funny but me. But, you know, vertical stretch. What's a vertical stretch? So let's take a good old parent function, the absolute value of x, okay? And hopefully by this time you are all familiar with what that looks like. It looks like you go up 1 over 1, up 1 over 1, like that. Same way. Okay. And now let's say I put a number on the outside of the parent with multiplication. So I do like y equals 4x. What would end up happening is I would now get the 0.14, negative 14, and then the 0.14 and 0, 0. It would look like this. It would look as if I vertically, along the vertical line, as if I stretched it out a little bit. And so the rule says that when you have a constant that you're multiplying on the outside of the parent, and that constant is bigger than 1, it stretches it. It stretches it vertically. Okay? And it has a point, and write this down because you're going to be asked some questions in my math lab about these points, with the point x, comma, cy. That number on the outside is multiplied to the y. Now, if I take that same function, let's say, and I do, and I'm gonna graph it again. I think I like to see it. So here's my v, here's my parent function. And let's say this time I put a fraction in front of it. Y equals 1/2 the absolute value of x. Y equals 1/2 the absolute value of x. Well, what would happen is, again, if I multiply those values by 1/2, it actually gets a little bit wider. I like to tell my students, fractions make you fat. Fractions make that graph go fat, make it go wider. But they like to use, on this lovely book, they like to say, oh, it vertically shrinks. The vertical line shrank down and it squished that V shape. So when y equals c times f of x, and c is a fraction, not negative, just between 0 and 1, which that's just a fancy notation for a fraction, it's going to shrink. And you're going to have that point x comma cy again. But this time you would multiply all your y values by 1/2. So, couple quick things to know about this number on the outside of your function, of your parent function. So when it's outside the parent, it's a vertical stretch or a vertical shrink. It's one of these when it's outside the parent. It's going to be a vertical stretch or a vertical shrink. If it's a fraction, that's what this is right here, it's going to shrink it. It'll make it wider. It'll push that vertical down and make it wider and shrink it. Whereas if it's a whole number, it's going to pull it up. So outside the parent, you want to multiply y, multiply your y coordinate by a factor of c. Okay? So vertical stretch and vertical shrinking. I still prefer fractions make you fat, but no one in the book likes that saying, so we're going to go with it. Second part, what happens if it's a horizontal? What if it's going this way? How do we know if it's a horizontal stretch or a horizontal shrink? horizontal stretch and shrink. So let me move this up for a second. This one, we're going to do the y equals square root of x parent. If you remember that one, looks like this. 0, 0, 1, 1, 2, 3, 4, 2. So that's your y equals the square root of x. So this one would be where I put the c value, the constant value, inside the parent, c of x. Okay? And what ends up happening is, with the point, you actually multiply your x value by a 1 over c, which when you multiply by 1 over c, that's the same thing as dividing by c. And let's let our c value be a fraction. Okay, so let me actually use our calculator, kind of look at this, because I did put it on here. I did. Okay, so clear. So let's see what happens if I have square root of x and then I put square root of 0.25x. So that first line is square root of x. And then that second line is the square root of 0.25x. So what would you say is happening here? Is it stretching it or is it shrinking that horizontal line? Well, to me, think about this like you can pull it or push this axis right here, this horizontal line. Looks to me like I would have to pull it and that would move that blue line down. So pulling is like stretching it out. So if I had y equals the square root of 0.25x, it would stretch it horizontally. So it would go like that. Stretch. Now, what if I instead made that c value not a fraction and I made it a whole number? What would you think happened now? So let's let c be greater than 1. And again, this would all be the same with the point x over c comma y. And again, just to show you, oh, there it is. Got that glare. There we go. So I'm going to go second square root of, well, I don't know, 5x. I'm going to turn this one off just so you can see what happens. You can turn it off by, see how that it's not highlighted anymore. You just hit enter. So there's the original. And there's the new values. And look what happened there. So I actually was shrinking this to push it, to almost push this blue line. I'm shrinking it and it'll push it up. Okay. So little quick comment to write on your notes. So if you're inside the parent, when that number is on the inside of the parent, depending on if it's a fraction or if it is a whole number, you want to multiply. And again, this will become important. That's why I'm writing it down. That's why I want you to write it down. I write these things down because I know what's going to be asked of you in the homework. Multiply the x by 1 over c. Multiplying by 1 over c, by the way, is the same as dividing by c. It's the same thing. Okay? So let's see what kind of questions would be used. I tried to write a few of them. on this one to help you out here. So the first one that I saw, which is kind of interesting, they're going to give you a graph, not an actual, like one of those parent functions. They're going to say, use the graph of y equals f of x. They're just calling it f of x to sketch the new graph y equals f of 1/2 x. Okay. And they do give you a graph, and let me plot the points for you if I'm looking correctly. So you have 2, -1. And then 0, 1. And then -1, 2. Oh, Mista said it was wrong. I'm sorry. That is not 2, -1. Sorry. 2, -1 is here. -1, -2 is here. Ignore this dot right here. I'm so sorry. I'm looking at a couple of dots on my page, so ignore that one. Sheesh. Here we go. All right, so they give you these dots. So, I mean, we can write them down. 2, -1. And then I had 0, 1. And then I had -1, -2. Okay, so now they're going to give you this. They want you to sketch y equals 1/2 x. So what is that actually doing? Remember, if it's inside the parent, right inside there, it's going to be a horizontal stretch or shrink. It's inside the parent, So what do? You multiply by 1/c, or you divide by c. Okay. So what is my c value? Well, that's my c value. My c is 1/2. This is going to be a horizontal stretch, because that c is 1/2. So it's between 0 and 1, which would make it a stretch. And so now what I have to do, if you look at the other side of your notes there, I take this and I take my x and I divide by c. So if I take my 2, my x value, and I divide by 1/2, 2 divided by 1/2 is 4. You can check it in the calculator. So 4, -1 would be my new coordinate to make it horizontally stretch. This one, you do 0 divided by 1/2. Well, that's not going to do anything. That's just going to be 0. 0, 1. For this one, you take your x, -1, and you divide it by 1/2. Well, that's going to be -2. And then your y value stays the same. So it's just the x that changes. So 4, 1, 2, 3, 4, -1, and then 0, 1 stays there. And then -2, -2 is there. So your this right here, what I just drew in red, would be the horizontal stretch of these 3 dots. And you'll have a question like that. So you just have to look to see, is it on the inside? Then you divide by that c value. If it was on the outside, then you would multiply the y by that value. That's why I put those little examples up in there. Okay, so that's horizontal stretching and shrinking, and then vertical stretching and shrinking. Then we have one more thing that could happen to these graphs, which is reflecting. Reflecting across an axis. So what does that look like? So let's just pretend I made up a function here. Here's my function, and this is again what they're going to kind of do. Something like that. Let's say this is the point 4, 5. Okay. And let's say I want to reflect this point over the x-axis. Here's my x-axis right here. Okay. And again, it's like a mirror image. Like this would be the line of symmetry. We'd want it to reflect, and you'd be like, all right. I mean, if you want to like go all crazy and be an artist, you'd be like, okay, I'm flipping it over here so it kind of looks like this, and then it goes like that. What would be that new point right there? Don't worry about this one. I mean, you could, but let's just worry about that one right there. Well, wouldn't it still be 4? It would still be 4. But now my y value would be -5. So when you reflect across the x-axis, your y value changes. Your y becomes negative. So you will have a negative on the outside. That is a reflection across the x-axis. X-axis reflection. So then, same idea. Let's say I drew this. Let's say I was like, whoop. There's my y equals f of x. And let's say this is the point 4, 5 again. And this time I want to reflect it over the y-axis. I want to go over that line. So you'd probably draw. You have to put the sound effects in there too. Something like that. So what is that new coordinate there? Well, again, let's see. If I count up, my y value would stay the same this time, but my x value would now be -4, +5. My x value would change. So that means that negative would then be inside the parent. And this would be a y-axis reflection. And again, you can test this in the graphing calculator. You can put in a couple of negatives into some of your parent functions, but you'll see it'll flip over the y-axis when the negative's on the inside, and this one, when it's on the outside, it flips over the x-axis. So you'll have some things like that. So now, I'll give you other examples that you'll see in homework. It'll say something like this: graph y equals -2 times x minus 3 squared plus 1 by hand. You're probably thinking, oh, they don't know that I have a calculator. Well, my math lab is a little tricky because they'll show you multiple choice graphs, but then they'll ask you certain words to make sure that you knew what happened, and so that you could actually do it by hand. Meaning, so if I said, let's go through each one of these numbers and what it means. So my parent function is a parabola. You should all know that, right? Y equals x squared is the parent. So I know if I were to do this, I would have good old parabola. So let's see what has occurred with each one of these numbers. So that +1, that's where I'm going to start. That +1 means that I'm going to take this parabola and I'm going to go up 1 with the vertex, with this point right here. I'm just going to move it up 1. We learned that last class. -3, you're inside the parent. Inside the parent, you want to do the opposite of what they always say, because I always want to go to the left, but that -3 means go to the right 3. All right, so I'm going to have to go right 3. 1, 2, 3. So I know my vertex is going to be right about there. Okay? Now, the 2 on the outside of the parent, again, go to your notes. That's why we take notes. The 2 is on the outside. Oh, this had a 4 on the outside. This had a 1/2 on. So I'm going to look at this one. The 2 on the outside stretches it vertically. It like pulls it up. So it's going to be quite narrow. Okay. So this is a vertical stretch by a factor 2. And then the negative, that's with the 2, that just means it's going to flip. It's going to flip over. Flip over what? Flip over the x or flip over the right? Well, if I'm on the outside again, it's an x reflection. So I'm going to flip over the x. And they will ask you what those mean. They will ask you what each number represents, and you'll have to obviously have some multiple choice there, but you'll have to look at it. So really, in my mind, I know that this U is no longer going to be a U. It's going to be upside down, and it's going to be a little bit narrower. And like I said, you'll have multiple choice for it, so you'll be able to see. And you can obviously put in your calculator. I'm not against that, but I'm just letting you know you need to be able to look at these numbers and know what they're talking about. All right, so that's another example that they'll do for you. Then I saw this one, give an equation. That would shift y equals the absolute value of x left 3. Vertical shrink by a factor of 2/3. Down 4 units and reflect over the x-axis. Give an equation that would shift y equals the absolute value of x, that's absolute value of x, left 3, vertically shrink it by a factor of 2/3, down 4 units, and then reflect over the x-axis. All right, so let's see if we can try to write this equation. Shouldn't be too hard. So we know this is our parent. Left 3, I'll start there. Left 3 means I'm going to go inside the parent. But I'm going to do the opposite. I want to write -3, but I know it's +3. So y equals the absolute value of x plus 3. And I'm going to leave some room because I'm probably adding more things around it. So I got that one covered. Vertical shrink by a factor of 2/3. Vertical shrink by a factor of 2/3. So again, looking at my notes, I mean, I'm really trying to make a point here. This is why we take notes. Vertical shrink, put that number on the outside, 2/3. Okay. Down 4 units. Down 4 units. That goes outside the parent also, but you'd write -4. So we got that. We got left. We got vertical shrink. We got down 4 units. Reflect over the x. Reflect over the x. Reflect over the x. Put the negative right outside. So there you go. There's your equation that would complete all those shifts. So you'll have a couple questions just like that on this homework. And one more. Given the function, well, let me move this up a little bit. Given the function where is it increasing? You have one of these questions again. Decreasing and constant on the open interval. I'm doing this again because I saw it in there and I just want to make sure there was a lot of information on that last section. So we're going to just do this again to double check. So they're going to give you a function. 1, 2, 3, 4. Give me a minute to graph it out. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 4. And it's going to be something like this. There we go. So they're going to give you a function. They're asking you, where is it increasing, decreasing, and constant on the open interval. And I know you're probably thinking, I should have given this in the beginning of class, but I'm pretty sure like this question is at the end of the homework section. So going back over this from the last class, open interval means everything is with parentheses. So you don't ever have to worry about a bracket. You do this like you read a book, from the left to the right. You have to start your pencil on the left. So even though the arrow's pointing up, we're starting on the left. Oh, and one more thing, I'm sorry. So parentheses, number 2, left and right. On x-axis. You only are talking about values on the x-axis. Where's my little highlighter here? Don't worry about the y's. I only want to know what's happening on the x-axis point. So it looks like my pen is going down. From where? Well, on the x-axis, you'd be like, oh, -4? No, no, no. It could be all the way out here. -100 could be. So we'd say it is decreasing from -infinity until where? Well, there's an x-axis point. Yes, but I'm still decreasing. I'm still decreasing. I'm still decreasing. I'm still right about here is where it changes. Where is this point on the x-axis? Oh, this is at 0. So I'm decreasing from -infinity to 0. Then what does my pencil do? Well, it starts moving up. Up until where? Well, it looks like it's increasing from wherever you left off, 0, to this point, which is what on the x-axis? This is the point 3. And then after that, it's remaining constant. What is remaining constant? Well, you're like, oh, it's at, no, don't look at the y. From 3 on over, it's remaining constant. Constant on the x-axis from 3 to infinity. These need to be on the x-axis. Don't worry about the y's. Worry about the x's. All right. That is 2.3. Now, it's 6:35. I'm going to give us a 5-minute break here. Maybe just grab yourself a little snack. It's not going to take long at all to just do the first portion of 2.4. But that's all I had for tonight, beside doing the onboarding activity. And then I'm going to let you start your homework. I mean, this is a big you're welcome right now, because when I look at stuff ahead of time, we're going to be going quite long. So I'm kind of still giving you a little bit of time here to catch up, get that book, make sure you're all signed into the book, make sure you're on the onboarding so we can finally move away from that and now actually focus on our lessons. But don't leave me yet. We're going to just do a little bit quick lesson of 2.4, just the beginning. But just take a little 5-minute break, get some water and whatnot, and we'll be back here very shortly.
Miss Estelle, I had a question really quick.
Go for it.
On the last set of examples that you just gave with the shift that you had, the vertical shrink with the factor of 2/3, where I was missing it when I was writing it down. How did we get the negative in front of the 2/3?
The negative is this last part right here. Whenever you have a reflection,
Okay.
reflection is going to be a negative. It just depends. The negative is either going to be inside of the parent, like next to Mr. X, or it would be on the outside. If it's reflecting over the X, it's on the outside. If it was reflecting over the Y, it'd be on the inside.
Okay, thank you.
You're welcome. Jeff, go sit down. My. Calm down. Jack. Get down. Get down. Shh, shh, shh. Come here. You're fine. I know. You're fine. Okay, if you can bear with me for a little bit longer, honestly, it's about maybe 2 pages here of notes and then done, and that's me writing very big notes. So, but I just wanted to get this part in because next week's class is, like I said, we have 2 lessons on Tuesday, very beefy stuff, and I want to make sure you really comprehend it. And then the rest of this class will be yours to start working on homework, get things done. I know some of you, even needed some homework from chapter 1 done too. So please use this time. Please use this time wisely. I'm trying to do this for you right now before we get into the big stuff. Hey, buddy.
Hi, Mama.
Love ya.
I saw one of your students.
You saw one of my students?
Yeah.
Who?
She had a brown shirt.
She had a brown shirt.
Brown hair.
Brown hair. Sweet.
With a ponytail.
I don't know. There's a lot of brown haired girls I teach. So, all right. Can you make sure Jack goes outside with Daddy, or bring him outside? Judah. Judah, can you take that too? Sorry. Bye. Thank ya. All right. Here we go. Joys of being with my kid. He just got home. All right. Let's see. What do we got? Oh, so this is really neat. Suppose I gave you a graph x minus 4 squared minus 3. Now we have been looking at this, and you're like, I totally know what this looks like because I'm so good at this right now. I know if we were to graph this, this is a parabola. I know that minus 3 means that it shifted down 3, 1, 2, 3. I know that minus 4 means it went to the right, 1, 2, 3, 4. And you got good almost parabola. And you're like, totally get it. Okay. So let's say I asked you, because this will never end. What's the domain? What's the domain? How wide is this thing? Hold on one second. Judah, shut my door. If I said, how wide is this parabola going to get? How wide is this going to go? Again, even though it looks like they're just going right here, they're going to keep going and going and going and going and going and going. They're going to get very wide. Oh, hold on. People are in the lobby. Who's in the lobby? It doesn't say. Okay, so how wide is this thing getting? Negative infinity to infinity. It's going to get really, really wide. What's the range? How tall does this thing go? Well, it only goes from here on up, right? And what is that number? Well, that would be -3. And we use brackets here because we're not talking about increasing or decreasing. So -3 on up to infinity. Now, this is what's cool about this absolute value function. What happens when you put an absolute value around that entire function? So what's really neat is, think about it. When you put an absolute value around anything, like I said, what's the absolute value of 5? You'd be like, oh, 5. What's the absolute value of -5? And you'd still say 5. The absolute value function makes this parabola, makes all these negative y values become positive, because everything would become positive. So this picture that I have right here would go something like this. It would go, oh, it's kind of terrible, but all that parabola right here, all these negative y values would come up. So write that down. All the negative y values are reflected across the x and become positive. Okay. So again, let's talk about domain and range, because they're always going to do that. Domain, how wide is this thing? It's still -infinity, infinity. It's still going to go the whole width of the x. But the range has now changed. The range, I don't have any negative values whatsoever for y. So my range is from 0 to infinity. So pretty neat, and you can check it out in your calculator. Remember, the absolute value function is math_num_abs. Math_num_abs will give you that absolute value function. And another example that you will see in this sections of homework, graph graph of y equals fx. They like to do this. They don't want to give you ones that you know for sure. They want to draw ones that you don't know. Graph y equals f of x and find the following. Oh, they're going to make you graph it. Okay. Oh, da, 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 da. Hold on, I got to get it drawn correctly. 1, 2, 3. So it goes here, 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 and here. Okay, so they're going to give you this graph, and they're going to say 4 things. They're going to say, okay, what's the domain of f of x, this function that I just drew? What's the range? And then they're going to ask you, okay, what's the domain of the absolute value of f of x? And what would be the range of the absolute value of f of x? So, domain, how wide is this thing getting? Now notice there's no arrows. So my picture is going from here to here. From this x point, remember domain is x's, to this x point. So from -2 to 3. And you do put brackets. Oops, 3. Because you have points, all the points in between, and they're closed at the ends. Okay, the range, how tall is this function on the y's? From here to here. So that would be from -1 up to 3. Now, let's say I took the absolute value of this graph. Now remember up here what had just happened when I took an absolute value of a function. Everything that was below the x-axis, all these y values bumped up and became positive. This y value down here, this one of 4 -3 became 4 +3. So just to give you a better picture of what the new graph of y of f of x, the absolute value of f of x is, these two, like this V shape right here, would now become up here. So this is -1, -1. It would now be +1. I drew this terrible. I drew my scales terrible, but let me highlight it. This highlighted would be the absolute value of f of x. Because anything that's negative y values go up. So now what's the domain of the absolute value? What's the domain of this highlighted yellow function? Well, it's from, again, let's say -2 to +3. That didn't change. It didn't change up here either. What's the range though? Well, now my range, remember, I don't have this section anymore because I took the absolute value. So my range is from 0 up to a height of 3. Okay? And so you'll have graphing questions about the absolute value and one like that. All right, and then almost done here. This is so sad. This will be our last little bit here. All of next week, we're going to solve absolute value equations and inequalities. These can get very, very tricky. So that's why I want to start it right now. So again, just bear with me. I'm sorry, but honestly, I'm getting you out way early tonight. So I know you'll be not too sad, but solving absolute value equations and inequalities. Solving absolute value equations and inequalities. Now, there are 3 cases that you could end up having for absolute value equations and inequalities. And we're going to write these 3 cases down. We're going to do one example, but really it's like 3 in 1, and then we'll be done. We'll go over this again next week. This becomes really, really important. Case 1. You could have an absolute value, ax plus b, and it equals k. Ax plus b equals k. So what that means is what's inside here, because again, remember, you take an absolute value, what's inside of it becomes positive. So the ax plus b could equal k itself. So you kind of like just drop the bars. Or the ax plus b could equal a negative k. Why is that so? Because if this right here equals negative k, and I take an absolute value, it becomes k again. So this is the first case you get. When you get an equal sign, you actually have to write 2 equations. One where you're equal to positive k, and one where you're equal to negative k. I've seen teachers that have done it this way. They've actually said, write this like it is, and then write the opposite of this here and leave it equal to k. I don't like that one as much. I like writing 2 separate equations, just like it is, drop the bars, and write it again, set it equal to negative k. So that's our first case that we could get with absolute value equations. The second case we could get is an inequality. So I could have the absolute value of ax plus b being greater than k. Greater. I like to say it that way because it helps me remember. Greater or. If you remember from algebra, there was something called an OR graph. Okay. Now the way to write out the 2 inequality equations that work out from this one is similar to this. You would have ax plus b is greater than k. You write it just like it is, as if it had no bars. Or ax plus b, flip the sign, flip the inequality, change the sign. And your graph should look like an OR graph. You will have answers located here. Oh my.
You're muted.
Miss Aceta, you're muted.
Thank you. Can you hear me now? I still mute. There we go.
Thank you.
Thank you. Bless. Okay. Then our third case. Ax plus b is less than k. And by the way, these could be equal to, I'm just doing it as less than k, greater. So less than has to be an and graph, if you remember from algebra. So you would write it just like it is, ax plus b less than k. You're going to solve that. And ax plus b, flip the sign, flip the inequality, change the sign. And you should end up with a graph that's an and graph is always in between. That's where your solutions lie. Okay? So we're going to do one quick example with each three of these cases, and then that'll be it. Now, I know it's like I said, this would be really a lot to do next week, plus we still have more to do. But I just want to go over this with you right now before we get too into it. So we're going to do 4 minus 3x, the absolute value of 4 minus 3x equals 2. And this is how they're going to do it on MyMathLab. Then they're going to have the absolute value of 4 minus 3x is greater than or equal to 2. And then they want you to solve the absolute value of 4 minus 3x is less than 2. Okay, same one, 3 different solutions, 3 different answers. So let's look at our homework and what to do. So whenever you see absolute value bars, write 2 equations, right? You got to write 2 of them. So write it just like it is, 4 minus 3x equals 2 without the bars. Then write it again, 4 minus 3x equals, change the sign, negative 2. And then solve. Subtract 4, subtract 4. I get negative 3x equals negative 2, x equals 2/3. Or this one, minus 4 minus 4, negative 3x equals negative 6. Divide by negative 3, x is 2. So that means I have 2 dots, one at 2, and then another one at 2/3. So my solution set, and this is how they're going to want you to write it, is 2/3 and 2. Whenever it's an equals, it's a solution set. It's got those funky brackets. So what would happen here and here? Because it seems like we're going to be getting the same values right here, boundary values. Well, you are, okay? And just to prove it to you, just to show you, this one is a greater than. I would write it just like it is. 4 minus 3x greater than or equal to 2 without the bars. Greater is an OR graph. So or, write it again, or start to write it, 4 minus 3x, flip the inequality, change the sign. And then solve. If we go to solve it, minus 4, we get negative 2, and then divide by a negative, you have to flip the inequality again, so that's 2/3. X is less than or equal to 2/3. This one, I minus 4, I get negative 3x is less than or equal to negative 6. Divide by negative 3x is greater than or equal to 2, because you got to flip it. Oh, so what happened here? So I still had those boundary points, 2 and 2/3. Here's 2, here's 2/3. But for this half, all my answers are less than 2/3. They're that way. And it's less than or equal to, so it would be a bracket. But for this one, all my answers would be greater than, that way. Now, how do I write that as a solution set? Your answers for x are from negative infinity to 2/3 as a bracket, united with 2 to infinity. This would be your answer. And look at it, it looks like an OR graph. It has this side or this side, just like I drew up here. So then this one, again, this should be an AND graph because it's less than So where do you think it's going to fall on a number line? I mean, we could solve it again. We could do exactly what we did, but we know our boundary points are going to be 2/3 and a 2. If it's less than, it should be an and graph. It should be in the middle. The answer should be in the middle. And this time I don't put brackets, I put parentheses because I don't have an equal sign here. So my answers would be parenthesis 2/3 to 2. And that's how you would solve an absolute value equations and inequalities, and how you graph them. Okay, so that's the beginning of next week. Now, it's 7 o'clock, and I know you're sad, but that is it. What I'd like you